Good afternoon, gentlemen. I'll be talking about Excel, Microsoft Excel. I'll try to explain how we can use Microsoft Excel in mechanical engineering. First of all, I'll share my screen. I hope there's no problem in.
All clear, hocam.
Huh?
Everything clear.
Everything clear. Okay, thank you. Now, Excel is what you call they call spreadsheet software by Microsoft. But there is another version of Excel which is completely free. If you want to use it, you can use it. However, anywhere I go, any computer I turn on, usually has 99% of the time, not usually, almost all the time, have a Microsoft Office program set available. So everybody pays for it. So why not make use of it? Keep in mind, in recent years especially, those fancy programs like MathLab, MathCAD, etc., cost hell of a lot. Although as a student, you can download it free, most cases, a crack version. Companies cannot do that. What I see is that these software companies encourage you to, they even give it to universities free to use, so that you can get used to it and ask it when you go to work somewhere. I'm not saying you shouldn't use it, you shouldn't learn it. Of course, that's a good thing to do, but keep in mind those are costly programs. You can only use them if it is worth it. In normal standard engineering jobs, tasks, it is much better and much cheaper to use a readily available free or almost free program like Excel, like GeoGebra, etc., because these programs are free. And I can tell you, anything that you learn as an undergraduate can be performed, all those calculations that you have learned as an undergraduate can be performed using Excel. I can bet on it. I can show lots of different examples using Excel. You can solve lots of complicated problems. The reason why Excel is very important is, number one, it is broad user base. Once you break the ice, once you get into it, you can, if you have a problem doing something, you can go to the internet. Since it is everybody is using it, you can find an answer to your question. In the internet, there are lots of sites, lots of places where you can learn something about Excel. It is compatible with multiple platforms. It can be used in PC, Mac, even in iPad, you can use Excel. It is, let me repeat, the most important thing is it is low cost. Any mathematical package that you use costs more than $10,000. Much more than $10,000. Now, think how much it will be in terms of Turkish liras nowadays. It is costly. It is really, whereas you already have a legal version somewhere, for example. You can graph your results very easily. It is powerful. It has very powerful capabilities inherent in VBA. If once you go into the macros, learn Visual Basic Programming, you can do sky is the limit, let me say that much. You can perform iterations, you can build in optimization using solver. This portion I will explain in the second part of next week, how to perform optimization using Excel, and how to write macros and use macros in Excel. That will be the second part. You can use instant calculations on each step for immediate feedback. So it is really something that, you see, as an engineer, in the old days, I had a slide rule to use. I don't know whether any of you have seen this. Maybe if your father is an engineer, you may have seen this. This is that slide rule. In 60s, up to 1974 or 76, in Metu, we were asking students to use this slide rule to perform all kinds of mathematical operations. I could use multiplication, division, taking the log, taking the cosine, etc., or using this instrument. After 1970s, the mid of 70s, we started using this calculator, scientific calculators, some of which are programmable, mine is programmable, but it is a very low capacity. And you are still using this calculator in your exams, in your homeworks, etc. Whereas everything has changed in the industry. Wherever you go, wherever you work with, whether it is a machine shop or an office, you will be using for a computer, and plus some software. Excel is a software. I mean, it is not a place. Keep in mind that any computer software is a tool. It is not the end. It is a tool that you have to use. You have to learn how to use it. You apply your engineering skills. Now, knowing Excel or knowing any other program is what makes the difference. Everybody learns, every engineer nowadays, whether from business university or somewhere else, they know how to use the drawing program. Whether it is NX, SolidWorks, CATIA, whatever, they learn how to use it. You have to make a difference. Engineering is not simply graphic, it is calculation. You have to perform, you must be able to apply all that you have learned to into real engineering tasks. So you have to learn, you have to be able to perform computation. Excel is a tool to perform those computations. Okay, make a difference. Let me say this. This is very important. There are more than, nowadays it has decreased to some extent, but there are more than 7,000, 8,000 engineers graduating each year. So you have to make a difference. What I will do is I'm not going to explain everything using PowerPoint, using slides. I have taken small notes. I think I have very few slides to show, but I will be mainly using Excel. So what I will do is turn on Excel, turn on an empty sheet, and try to explain most of the things using Excel itself. Excel has cells, rows, columns. Whenever you turn on Excel, you see humongous number of cells. I don't care how many cells. I used to say it has so much rows, so much columns. It's not important because you cannot fill it anyhow. It is a huge sheet. It has you can create several sheets. Right now I have one, but I can create 10, 12, 13 sheets. Each cell, whenever it's turned on, has a name. Each cell has a name. The cell name is addressed as the column letter, row number. For example, whenever I'm over here at this cell, it says K17. This is the name of the cell, K17. Okay? Normally, the cells have relative cell addressing, meaning, okay, I'll give an example to that in a minute. You can make it an absolute cell addressing by naming the cell yourself. I'll show that in a minute. Let me open a cell. This is what most of your instructors use. You have a number of students. You have the student number on one column, the name, the surname on the other column. The student gets grades, homework 1, homework 2, project 1, project homework 3, project 2, homework 4, midterm 1, midterm 2, final. This is completely, it has nothing to do with a grading of any class. So I'm not, so now you can, number one, into each cell, you can type the grade each person, each student had for that homework or for that project or for that midterm or for that final. Now, this is the data. You can enter any sort of data. You can fill in any sort of data and store it in Excel. It is a data storage platform, and it's a huge data storage platform. That is why the management people, the finance people, all use Excel. Next, you see, I will be giving grade whenever I'm giving a grade. All these grades that I have different weights on the final grading. Homework has different grading, and each homework can be of different grading. Project can be of different weight. Midterm has different weight, and final has a different weight. What I can do is, I can write weights. This homework 1 has weight 1 out of 100. Homework 2 has 1. Project 1 has 6 weights. Homework 3 has 2 weight. Project 2 is 8 weight. It has weight 8%. Homework 4, midterm 1, 20% each, final 40%. The sum of which is 100. The way I take the sum is, let me show it, is equal to sum, open up parentheses, mark all these cells, close the parentheses, you have it. Whenever you are entering, you can enter anything on these cells, numbers or letters, literals, etc., currency, etc. If you are going to perform a computation, you must either first type equal sign, as I have done over here, or plus sign or minus sign. Whenever you type an equal sign, the computer understands that you are not entering data into that cell, but you are going to perform an operation between those cells. Now, what I can do is, okay, the way I determine the final grade is I place equal sign. I take homework 1 grade of Abdurrahman, multiply it by its weight. I'm going to divide it by 100, but I'll do it as a total later. Open up parentheses, plus take this grade, multiply it by its weight, plus multiply it by its weight, plus do this like this. Sorry. Oh. Plus times plus times plus times close parentheses divided by 100. Okay, this will be the final grade that you have. Now, if I do it like that, whenever I have to repeat this process for every student, for each student, I have to repeat the same. I have to type in all these again and again. Whereas when I look at it, I have to keep these weights the same for every student, whereas these grades must change for each student. In such cases, I have to have these cell addressings, these cells, to be relative because they will change according to the student, whereas these weights must be fixed. They must be the same for every student. So what you do is this. You go to the formula. I could have done it before, right? But now I'm doing it. The cell that you want it to be fixed, you type in F4. You see $sign in front of D and in front of 3. Go to E3, F4. F3, F4. These are the weights, G3, F4, H3, F4, F4, what this does is, it keeps those cells that you have pressed and you are seeing as $sign in front. You are fixing those cells. Whereas D6, H6, etc. are not fixed. In that case, the result is the same. But when you pull this down, please look at the formula. The cells which you have not fixed change. It is Tarık's grades for each one of those, whereas the weight is the same for every student. Okay? So, next, what you do is click like this. You have calculated the final average of every student in the class as such. This is what all your instructors are doing. And another thing is, if something happens, and if you think that you are not fair, you should not give a weight of 8% for project 2, but you should change it to 10, while decreasing the first exam to 18. You automatically perform that operation. This is what is known as relative cell addressing. You have those cells which are not fixed, those cells which are fixed. You can use them alternatively. We'll see the other examples to this later. This is a very important concept. Besides that, you have all kinds of functions in Excel, or formulas. Any calculator, you have more than any calculator has. Okay, you have all kinds of formulas. Math trig functions are the ones that you will usually use, and there are plenty of it. All functions are available. If you want, logical functions, math trig functions, cosine, arc cosine, tangent, atangent, all sorts of functions are available. All kinds of functions are available. You also have logical functions. I'll try to solve an example in a minute. Let us consider a simple equation. No, I will not do that. Let me first discuss matrix operations. If I have a matrix, I will type a matrix myself, 1, 2, 3, 4. I'll have 4 by 4 matrix, 3, 5, 7, 9, 2, 8, 8. It's, just, I'm simply typing numbers. So it should not be, sometimes I say something, but I type something different. It's okay. Okay. And then I'll have a column vector, 4, 6, 7, 8. I have 4 equations, 4 linear equations in 4 unknowns. x1 plus 2x2 plus 3x3 plus 5x4 is equal to 4. 3x1, 5x2, 7x3 plus 9x4 is equal to 6, etc. as you go on. I want to determine x1, x2, x3 values. This is a matrix. A, X is equal to B. I'm sure all of you have had linear algebra, so you know what I mean. Now, normally, you have to take the inverse of this matrix, multiply with the column vector B to obtain x1, x2, x3. But before that, you have to know that the determinant of this matrix is not equal to 0. If the rank of this matrix is not equal to 4, you don't have a single solution, you have multiple solutions. If the determinant is different than 0, then you have a unique solution. So what I have to do is first I have to determine the determinant of this matrix. Go to the math trig functions. If it is matrix, it has to start with M, keep that in mind. Over here, you will see M determinant, returns the matrix determinant of an array. Click on it. It asks you What is the matrix whose determinant you want to find? Mark these 4 cells, click. The value is 120. Move this somewhere over here. This is the value of the determinant. So you have a unique solution. Now I have to determine the inverse of this matrix. In that case, the inverse of a matrix has the same rank as the matrix itself. So I have to mark a 4 by 4 area as such. Again, click on math and trick functions. Here you see M inverse. Click on M inverse. It asks you the matrix whose inverse you want to find. Mark these 16 cells. But please, please, do not press enter, do not press OK. I'll do it myself. Oh, in the new version, it has done it. Normally, it will not give you this result. I mean, it will give only the first one. Now, I think they have changed it. Oh, this is 2020. In the early versions, it will only give one result, this first element of the array. Normally, I would recommend you to click Control, to press Control and Shift key, and then press Enter. Normally, that's the case. How do I know that this is the inverse matrix of this matrix? A very easy way to prove is multiply these 2 matrices. The result will be an identity matrix. Has to be an identity matrix. Mark these 4 cells. Use the 3rd matrix operation. Matrix multiply. M mult. M mult. The first array that you have to multiply is this array. The order is not important in this case. The second array is this array. I will use the previous version, Control Shift Enter. Now you don't see, you see numbers different than, let me enlarge the view so that 140 is good enough, okay? You can see, keep in mind, any computer program has to do everything numerically. And Excel is no exception. It carries out 16 digits. Anything beyond 16 digits is null. If it chops out those 16 digits, you will end up with 10 to the minus 15, 10 to the minus 16, sometimes even 10 to the minus 12, etc. As far as I am concerned, those values are 0. We are engineers. We are not, we don't have to be perfect. If you want, format cells, number, keep 4 digits. Now you see a good identity matrix, the diagonal elements being 1, other terms being equal to 0. Now I want to determine x1, x2, x3, x4. Mark 4 cells. In order to determine the result, I have to multiply the inverse of the matrix by the column vector B. And in this case, order is important. Formulas, mathematical functions, M again, M mult, multiply with Control Shift Enter. That's your result, x1, x2, x3. Okay? Now, besides this, I'll show you a few different ways of doing it. I will take these values, Control C. Now I'll show something else. Paste it as a number. I'm in here I have the formula, M mod. Here I have, cancel. Here, these are numbers only, okay? What I will do is, I will erase all these. Now what I will do is, first of all, mark 4 cells on a column, and then equal, I'll perform those operations myself. M mult is the multiplication. Open up parentheses, M inverse, open up parentheses, these cells, comma, in some computers, you will see a semicolon. That will be semicolon. It doesn't matter. B. Control Shift Enter. I think you see that you have the same result. Sometimes, instead of using the cell addresses, in here I have used the cell addresses, as you can see. What I can do is, I can give names to these cells. For example, in here I have typed F4 to give to fix it. What I can do is like this. Go over here, this cell. I will call it weight 1. Call this weight 2. Oh, I'm sorry. This was 2, right? 2%. No, 1. I have to type it over here as the name of the cell. What I'm doing is I'm giving a name to that cell. I'll do it for only 2 of them. Now, in the formula, rather than putting the $sign in front, I can write weight 1, and I can type weight 2. I can do this for every cell as well, for all those cells that I want to fix. As you can see, that will also do. This time I have given a name to that cell. However, please, do not give too many names. In that case, you will be confused. You will be confused. There will be too many names running around, so you wouldn't know which is which. Only use special names for those cells, for some constants that you are going to use over and over. For example, one constant that I've used over and over is converting degrees to radians. Every computer performs mathematical operations, trigonometric operations, using radians as the angle. So you have to convert degrees to radians, because we can visualize degrees, but we cannot visualize the radians. So each time you have a degree, you have to convert it to radians, and you have to convert radians to degrees. For that, what I do is I go to a cell that I know I would not use, equal pi, pi, open close parentheses, is pi in Excel, divided by 180. When you multiply this value with a degree, it will convert it to radians. When you divide this number with this value, it will convert radians to degrees. So what I do is mark over here, give a name to this cell, and that is D-R. I use conversion, etc., but D-R is a good name that I will remember. Please, please do not use names to all these cells, and then in that case, you will be confused. There's another way, and that is naming need not be for one cell. I can mark all these for 16 cells, and I can call this matrix A. The name that you are giving should not conflict with the standard Excel names. For example, you cannot call it A1 or A2 or B1, B2, because those are the cell addresses. So I call it matrix A. And I will call this vector B. Now, I will be able to type something very simple. Is equal to M mult, open up parentheses, M inverse matrix A, comma, vector B, close the parentheses. Excel does not differentiate upper and lowercase letters. The way I do it is I usually write it as a lowercase letter and give names in uppercase so that when I press enter, those names has to change. As you can see, I have obtained the same number. And notice the names have changed from what I have written to capital letters. This is a solution of a set of linear equations. Okay. Now, let us consider graphing in Excel. I will consider several functions. The first function that I'm going to consider is f of x is equal to x cubed minus 3x squared plus x minus 1. And I want to plot this function between minus 5 and 5. The next function is y is equal to x cubed over e to the x minus 1 between 0 and 12. And the third function is a parametric function. T is running parameter, xy, x is equal to e to minus at cosine omega t, y is equal to e to minus at sine omega t. Between 0 and 100, a 0.05, omega equal 0.5. Now, what I will do is, this was, okay, that I will delete this from a note. Now, I will turn on a new sheet. This was class list. Now I have a new sheet. First of all, I will plot, let me, you can do everything that you do in an Office program. You can copy and paste whatever you have. This is the function that I want to plot. Usually, the coefficients can be anything. So what I will do is A3, A2, A1, A0 will be the coefficients. Usually I don't try to do it like this. I use subscript, so I will erase this. First, I will say A0 first. If I want to use subscript, this is what I do. Mark 0, format cell, subscript. That will give you A0. Increase the size so that we can see. And then pull it down, you will see that the subscripts will change. A0 is -1, 1, -3, 1. These are the coefficients of the polynomial. I want to plot this between -5 and +5. What I will do is like this. In order to plot some function, usually what we do is we select a number of points, determine corresponding to that, determine f of x, and mark those points on a graph paper, and then join those points with a smooth line. This is exactly what we shall do in Excel. First of all, we have to select a set of x values between -5 and +5. If the function is smoothly changing, you can take big increments. If the function is changing abruptly, you have to take small increments. What I will do is I will take 0.5 increments between -5 and +5, and I'll do it like this. -5 minus 5.4, 4.5 minus 4.5 minus 4. Maybe that's not enough, so minus 3.5. Then what we do is, in Excel, mark these 4 cells, go to the bottom right corner, your cursor changes to plus sign, pull it down. It fills in automatically in our arithmetic progression. These are the x values. F of x values will be this function, equal to, open up number 1, A3, F4, you keep that in mind, that's going to be constant, times this value to the power 3. You get that cap. Let me erase it. First, press Shift 3, you see nothing. And then press 3, you see 3 to the power 3. Plus A2, F4, times x value to the power 2 plus A1 F4 times x plus, and then F4. It has the value of 206. Now, if you have done this correctly, you don't have to retype anything. You go to the bottom right corner, your cursor changes sign, it changes to plus sign, double click. That's it. Next, if you have f of x versus x, the next thing that you do is insert graph, smooth line, select data, click on it, select data, add X values. Oh, sorry. Y values. This is your graph. Now, you can change the shape of this graph tremendously. I mean, you can do all sorts of things. For example, font, let me start with font. It is size 9, change it to 16, make it dark, make it bold. Font 16, make it bold, make it dark. Okay. Give a name, polynomial, just for the hell of it. Labeling, click on it over here, text titles. F of X, it is very small. Mark it, make it 20. Oh, I haven't marked all the cells. Okay. Where's, okay, X is title. Over here, I'll type X. Of course, it will depend on what you have, what graph you have drawn. Now, consider this line, format data series. Click on it, solid line, make it red, increase the thickness. If you want, you can change the dots, normal line or any kind of a line. I'll keep it like this. And then you can click on the markers. First, let me show this. Format axis, solid line, make it black, but increase its thickness. Over here, increase its thickness. You can do all sorts of things, okay? You can click on it, format plot area. You can solid fill, gradient fill. Of course, you can change the color, solid fill color, any color you like, gradient fill, or as you can see, you can do all sorts of things. Let me do it like this. Pattern fill. You know, there's no limit to this. If you want, I can spend half a day showing all kinds of different shapes. Now, but I would recommend one simple thing for all these. And that is, if you are going to give this as a report, Please do not use any color. Use black and white. If you have more than one curve, change the type, from solid line to dashed line, dot line, etc. And keep everything black and white, and get a copy of that to give as a report. If you are going to present something, if you are going to prepare a PowerPoint, in that case, make it as colorful to your liking, to your taste, okay? You can do all sorts of things in that case, because having a good presentation is an important step in expressing yourself. So in those cases, you are free to use any color. But if you are going to write a report out of that, normally those reports are black and white. So keep black and white. I have something else which is important in this case. Let me see. Okay, I have enough time. Notice, I think, I'm not sure, but there's only one root. Let me enlarge this to see whether I have. Yes, I must have another root or somewhere in here, but I don't see it. -6, -3, -1. But I know I have a root between 2.5 and 3. I have a root between 2.5 and 3. I want to determine that root. Can everybody see that? So what I do is, let me copy these, Control-C, Control-V, Control-C, Control-V. I have simply copied this portion. You see, it is the same function, so everything is the same, no problem. I want to make this value equal to 0 by changing 2.5. If you want, I can spend a little time like this. 2.6, hey, it's getting close. 2.7, it is negative, but it is getting smaller. 2.8, hey, it's plus, so it must be in between 2.7 and 2.8. Then 2.75. Hey, it's much in between 2.75 and 2.8, etc., etc. I can do it like that. But instead, Excel has a very good, powerful, simple tool to use. And that is goal seek. If you press data, what if analysis, you have this menu, goal seek. It sets cell, this cell, to value, if you want to determine the root, 0, by changing cell, this cell. Change, set this cell to 0 by changing X so that this cell becomes 0. Click OK. It is 10 to the -5. The result is 2.76, in line with what I have said before. 3.5, 10 to the -5. As far as I'm concerned, it is 0. But if you say, no, I should be able to find it more precisely, in those cases, what you should do is you should change the adjustments you have in Excel. What you have to do is go to File menu, go to Options menu, Formulas. Here, it finds that result in an iterative manner. So right now, it performs 100 iterations, and the maximum change is 10 to the minus 3, right? Add a few zeros over here, add a few zeros over here, correct? Click OK. Now, again, let me go to 2.5. Again, click on f of x. Go to what if analysis, go seek. Set cell to 0 by changing cell, this cell. Okay. Now, what do you see? 10 to the minus 8. That's good enough. If you want, you can add more zeros. I don't care. Okay, that's how you do it. Another way of using this goal seek, this is a very, very good tool. It is one parameter tool. Another way of determining using goal seek is, let's look at over here, this function. I want to determine the value of the function, the value of x, when y is equal to 150. What is this value of x when y is equal to 150? You see that 150 is in between 4.5 and minus 4.5 and minus 4. So I can, okay, I will type minus 4.5. Or let me do it over here. Go over here, click what if analysis, click goal seek. I want that point to have minus 150 value by changing cell, this minus 4.5. This is so common in engineering. You have a formula with which you can calculate a value, but you want the result to be equal to something, and you want the parameter that you are free to change to have to obtain the value of that free parameter. Okay? Now, when y is equal to minus 150, I know x has to be equal to 4.41555. Or, you can do lots of things. 50, for example. Go over here, go seek. I want this value to be equal to 50 by changing this value 5. Okay? It is a very simple but very powerful tool to use. I think I will solve this problem. This is more interesting. So Control C. And A is equal to 0.05, omega is equal to 0.5. Now what I do is, first I will type A. Oh, shall I? Let me do it like this. A, I type 0.05. W, omega it should be. So what I do is this. Click on Times New Roman. That's the type used for that letter. Simply type symbol. That's what happens. Point 5. Now, this is the function. Xt is going to run from 0 to 100. X and Y. First of all, I have to fill in t from 0 to 100 by certain increment. I'll take one increment 1. 0, 1, 2, 3, 4. That's enough. Go to 100. Oh, too much. Okay. Now I have to calculate this. E to the is equal exp, exponent, minus A, keep in mind that it has to be fixed, absolute cell addressing, F4, times T, close parentheses, times cosine omega, again keep in mind that you have to press F4, times T. Please think what will happen if you don't have this absolute and relative cell addressing. It will be a hell of a problem. I think you can check it. If it is 0, e to the minus 0 is 0, cosine omega t is 0, cosine 0 is 1. So this is correct. You have to type this equation. Of course you can type it, but I'm lazy. What I do is this. This is a different way of copying this formula. Mark all these cells. This is like copying a word in Word file or in any other. Control C. I have not I have simply copied the formula itself, not the operation. Go over here. Control V. You see, the same formula, exactly the same way, is typed over here. And of course, it is the same value. It has the same value because it has the same input. Now, all I have to change, if I look at these two functions, all I have to change is change cosine to sine. That's a very simple way of doing it. All other terms are going to be the same. Okay? This is a simple trick which I would recommend all of you. Now you have x and y values for 0, t equal to 0. Are you going to type this 100 times? No, hell no. Go to the bottom left corner, right corner, double click. You have obtained all the values. Let me decrease the size. Now I am going to plot it. Insert. But before doing that, I will do something. This is another trick, or not trick, simplification that I use to make life easier. I have left an empty row over here. Insert smooth line like this. Select data, add. For X values, it's going to run from 0, Control, Shift, and then press down arrow. You have all the values. For Y component, take the X value last term, Control, Shift, up arrow. You go to the top. Now you can see the reason why I have left an empty space over here. It stops. This is the X, f of X, X of t. Okay. Add X values again. Y values. You see, the two are 90 degrees out of phase with respect to each other. The two are 90 degrees out of phase, as you can see. Of course, I'm not going to spend time to give labels, etc. Without that, the labels, a curve, a graph is not complete, but I'm not going to do that. This is damped vibration, and the two oscillations are 90 degrees out of phase. Now let me mark these and erase it. I have, by the way, you can plot 10, 20, 30 different curves on the same graph, no problem. You can plot as many graphs, curves as you like. But there's one thing that I like, and that is, this is, rather than complicate all the curves, I have only just one curve like this. What I can do is, look, go to the X values, your cursor changes arrows, plus sign with arrows, move it. What happened? It is Y versus T. Move it, X versus T. Now another thing is, what will happen if it is X, Y versus X? Sorry. This is known as Archimedes' spiral. It is the vibration in two directions. It oscillates back and forth, and then it stops at the middle. It is a pendulum moving in two directions, okay? Okay. Let me consider another problem. You see, I'm going to add sheet by sheet. I have plenty of sheets, so that's it. The problem that I'm going to tackle now is a set of nonlinear equations. Those of you who have taken ME 301 mechanisms course, you know there are certain number of mechanisms with which you can solve directly. And whereas there are some other mechanisms for which you have to solve in an iterative manner. You cannot obtain a closed form solution in these cases. This is when you write the loop equations. Each loop equation has more than 2 unknowns to be solved. In this case, this is a 6-link mechanism. Over here, I have a slide. When I write the loop equations and then take X and Y components, the first loop is A0, A, C, A0. The second loop is Q, B, C, Q, both of which are triangles. For the first loop, A2 sine theta 1, 2. A2 sine theta 1, 2 is this length, horizontal length, is equal to S34 sine theta 1, 4. A2 cosine theta 1, 2 plus S15. This length is equal to S34 cosine theta 1, 4 for this loop. You can write the in context numbers and then separate the real and imaginary parts. You will end up with the same equations. This length is A1 plus S15. This QC distance is equal to A4 length times cosine theta 1, 4. S16, this horizontal distance, QB distance, is equal to A4 sine theta 1, 4. You have 4 equations. Notice you cannot solve theta 1, 2 is given. Unknowns are theta 1, 3, theta 1, 4, S15, S34, and S16. 4 unknowns. As you can see, you cannot solve these equations easily. Okay? You have to refer to iterative solutions. Now, let me assume theta 1, 2 is equal to 50 degrees. This angle is 50 degrees. And let me assume from the figure that I see, theta 1, 4 is 25 degrees, which is half of this angle. I guessed it. S15 is 500 millimeters. S34 is larger than that, 800 millimeters. S16 is 300 millimeters. These lengths, A0A is equal to A2 350. CB A4 is equal to 1,500 millimeters. A0Q is equal to A1 700 millimeters. Now, if I assume these angles, these distances, the value for these unknown variables, and if I substitute them into these equations will not be satisfied. They will be in error. If I substitute it into the first equation, it will not be satisfied exactly. There will be some error that I will call epsilon 1. If I substitute into the second equation, it will be epsilon 2, epsilon 3, epsilon 4. Just these equations. Now, my aim is to equate epsilon 1, epsilon 2, epsilon 3, and epsilon 4 equal to 0, while changing the values of these parameters that I have assumed. These values I have assumed, these 4 values I have assumed. I can change those parameters to come up with these epsilon values to be equal to 0. I can sit in front of the computer, write these formulas, and start changing these values over and over, till I come up with a solution. That's one possibility, but it will take you at least a day for one 50 degree angle. Instead, I have a similar to goal C. You see, goal-seek has one parameter, whereas in this case, we have 4 parameters. It is not the same. Similar to goal-seek, if I have an objective, I can make it equal to 0. But I can, if I have only one objective. But over here, I have 4 objectives. I have to make all these 4 epsilons equal to 0. In order to reduce these 4 objectives into a single objective, what I do is I define a new epsilon equal to all these epsilons squared, summed, and taken the square root. Now, epsilon is going to be equal to 0 if and only if all these epsilon values are equal to 0. If any one of them is not equal to 0, epsilon is not going to be equal to 0. This is positive definite, as you can see. It cannot take any negative value, correct? If any one of these epsilon has a value, it will be, if epsilon will not be equal to 0. Only if epsilon is equal to 0, this equation will be satisfied. So what I do is, I move it. I have a new cell. First of all, I type A0A 350. Now I come over here, mark 0. 350, not 359. Sorry. A0A, CB is equal to 1,500, and A0Q $700. Let me bring that. I would very much recommend you to put figures, etc., into Excel sheets. This you can do very easily, even if you draw it freehand, or even if you write a formula in freehand on a sheet of paper. Take your iPhone, take a photo, image of that, whatever you have, and paste, copy and paste it into the Excel sheet. Because later on, you see, whenever you are using Excel, you are not doing it for once. If you prepare something good, you will be using, you can use it several times. And this is very, it saves you from doing the same thing over and over again. Once you prepare something, you can use it over and over, usually. Okay, now I have those values. Next, I have theta 1, 2 as 50 degrees. Let me make it good. First, make it symbol, and then mark this cell. Also, let me do it like this. Increase the size. And then I have S theta 1, 4. Let me show that as well. 1, 4. S1, 4. Sorry, S1, 5. Let me, okay. If I do it like this, it will be easier. S15, S34, and S16. Center it. Theta 14 is assumed value is 25 degrees. S15 is 600 millimeters. S34 is 800 millimeters. That's what I have assumed. S16 is 300 millimeters. Let me stress this. These are the values that I have assumed. This is the exact value. Theta 12 is 50 degrees. I don't know exactly what theta 14, S15, S34, S16 is. Those are the exact values. This is the exact value. These are the exact values. Now, what I do is, Control C. I am going to copy those formulas. Control V. That's it. I will say F1, formula 1, is equal to A2, A0A. Oh, I have to convert these to radians. Is equal to, I'm not going to do anything, this value times pi over 180. Do the same thing for this one. These are the values in radians I need. Is equal to A2 times sine of theta 12 minus S34 times sine of theta 14. If these values that I have assumed in red are correct, this whatever what I have typed will give me 0. It is not, it is minus 69. F2 is equal to, please check the formula, A2 times cosine of theta 12 plus S15 minus S34 times cosine of theta 14. Let me repeat, if I had done it, I have assumed it correctly, this would be 0, but it is not. F3 is equal to A1, A0Q plus S15 minus A4, CB times cosine of theta 14. This is not 0. F4 is equal to S16 minus A4 times sine of theta 14. Ooh, it's a big error, as you can see. Let me repeat, you can sit over here and start changing these values. Let me see what will happen. Oh, it has increased, so I will change it to 400. It has decreased, and so on and so forth. I'm not sure, I'm doing this the first time. I don't know whether I can have a convergence or not. What I will do is, I will say equal SQRT square root this value squared plus this value squared plus this value squared plus this value squared in square root. 270. My objective is to make this equal to 0 while changing these values. These values I can change. Now, although I said Excel has a function, as something that will solve this problem, normally, usually in your programs, in your Excel files, the ones you may have, if you have not used it, this is not turned on. What you have to do is go to Options menu. You have seen formulas, click iteration, maximum iteration, maximum change, etc. that you have seen. Over here, you have add-ins. And you have Excel add-ins over here. Click on it. Go. In Excel, there are 4 add-ins that you can add. I'm not using $3. I'm only using solver add-in. Click on the solver add-in. Error currency, I don't have too much error, so I cannot use it. An analysis toolpack is good if you are going to perform statistical analysis. This is good for people working with money, projecting something, etc. But you have to check solver add-in. Okay. When you check solver add-in, go to Data menu, pull-down menu. Here you have the solver. Here you have what if analysis. Here you have the solver. This solver, you will see it in the second seminar as well for optimization, is a so powerful, so useful tool, you won't believe it. In this solver tool, your objective is to make this value equal to 0, value of 0. Minimization, maximization, we shall use for optimization. By changing cells, which cells are you going to change? You are going to change these cells. GRG nonlinear is an iterative gradient search method. Those of you who have taken numerical methods, this method is very closely related to Newton-Raphson method of root finding, okay? Similar to root finding in using Newton-Raphson, but it's a little different. Maybe not taking the derivative, it's the second method maybe you may call, okay? GRG nonlinear. The aim is, let me repeat, make this value equal to 0, because that will make all these 4 equations results 0 by changing these variable cells. This is the result. You can have constraints. In this case, I'm not placing any constraint on these values. You can also use evolutionary. This is genetic algorithm. Don't use it in this case because you don't want to set limits. In case of evolutionary genetic algorithms, you have to put limits on all the parameters that we are going to use. So we are not going to do that. So we don't want to use evolutionary algorithm. We use GRG nonlinear. And then we click solve. There's one other algorithm that we cannot use, and that's simplex. That is for solution of a set of linear equations. GRG nonlinear, and then click solve. Can everyone see what happened? This is so fast you don't believe it. This is the result. Now, for a mechanism like this, 10 to the minus 3, these lengths I gave as millimeters, and these are quite long, okay, 1,500 millimeters. You cannot measure anything less than 10 to the minus 2. Even if you are going to measure something in the order of 10 to the minus 2, you need a micrometer. Usually, if it's in a machine shop, you will measure in terms of 10 to the minus 1, tenth of a millimeter. And these mechanisms are usually constructed with 10 to the minus 1 tolerance. So that means these errors, as far as I am concerned, are equal to 0. Okay? These are the things that you cannot possibly measure. If you don't think it is so, please go and increase the number of iterations, increase the number of iterations, decrease the change amount, so that you will end up 10 to the minus 4, 10 to the minus 5. As far as I'm concerned, this is equal to, this is good. Now what I can do is...
John, can I ask something?
Of course.
What's the difference between what-if analysis and solver?
Solver, what-if analysis, in case of what-if analysis, in GoSeek, you can only have one parameter. In here, you have 4 parameters. In solver, you have more parameters. Okay? You cannot solve this problem using GoSeek. You cannot set this equal to 0 by changing one parameter. You have 4 parameters to change. Is that agreed? 4 equations to be satisfied. Is that agreed?
Yes, hocam.
Meaning GoSeek is good. GoSeek is good if you have a function changing with one variable. Whereas in this case, this value is changing by these 4 variables. Is that agreed? 4 parameters that you don't know.
Yes, hocam, I understand. Yeah. Thanks.
Now, what I can do is, this is very interesting. Control C, go over here, paste options, paste special, transpose. For a value of theta 1, 2, let me Control C. I think I can do that as well. Let me check that. Control C. Transpose. Okay. For 50 degrees, theta 14, S15, S34, S16 are these values. Fine. Now, let me increase this angle to 55 degrees. Believe me, I'm much closer to the solution than what I had before. As you can see in the previous case, this error epsilon was 200 something. Now it is 30 something. All you have to do is Don't change anything, solve. Now, Control C. Take the transpose, 55 degrees. Can I do it for every 5 degrees? Can you see that? 55, 60. The solution I have one step before is the guess value for the next step. I can solve this problem for 360 degrees as such. Very easily. I don't need any special program or anything else, as you can see. I have too many things to say. I think I'm going to slow. I'm not going to complete this. Okay, I can, as you can see, you can go on and on. The next problem that I'm going to solve is what I have solved in GeoGebra. I have a spring. I want to determine the spring constant, and then I'm not going to do the second part in this case. I want to determine the spring constant with this data, okay? What you do is you hang weights to the end of the spring, and you measure the distances. And outgoing from that, F is equal to Kx, as you know. Force is proportional to the elongation times the spring constant, what we call spring constant. We measure these values. All these points, data points, do not lie on a straight line. And another thing is, the weights, the force that we apply due to gravity, the weights are exact. F is exact, but the amount you measure is due to error, is prone to error, meaning it depends, the amount, the length that you measure will depend on the person, will depend on the instrument that they are going to use, will depend on the temperature as well, and will depend whether the room conditions, etc. So the error is on L. The weights are correct. That's very important. I have already those data points in an Excel sheet, but I'm not going to use that Excel sheet. Where is it? This is open. Book one Excel. No, I'll close this. The spring data, I'll Control C. Let me do it like this better. Control C, close this, add a new sheet, Control V. I have to fit a line through these data points. And those of you who have taken numerical methods, all these data points need not lie on a straight line. What we do is we minimize the sum of the errors squared. Okay, we try to minimize the sum of the errors squared. This is known as least square minimization. In this case, notice F is equal to Kx. This is the spring equation. However, let me repeat. X, these lengths, are prone to error. And the weights, these F's are exact. So because it's certified weights that you use, those are exact. Let me change these values to Newton and meter. What I do is take this gram, divide it by 1,000, multiply it by 9.81. Am I correct? It will be converted to newtons. 0 is always 0. Okay? Is that correct? 0 is, okay. That's the value. If it is in centimeters, I have to take this value, divide it by 100. 1 meter is 100 centimeters. Those are the values. When plotting, let me repeat, this is very important. I have done this using GeoGebra, but as well, I do not use a curve. I use simply plot the data points. Because if I draw that curve, it will be a saw type, a sawtooth type curve. So we don't draw a line between those data points. Click on it, select data, add. X values are the forces. Oh, sorry. After 4 hours, I'm prone to make a mistake. Y values are the lengths that we have measured. However, notice in this case, let me add axis title. This length is X. This is F. Horizontal axis is F. So the result that you'll find is not F is equal to Kx. This slope is not F is equal to Kx. It is X is equal to 1 over K F. Can everybody see that? This equation, what you will obtain from this curve is 1 over Kf. F is the horizontal axis, X is the vertical axis. That is the data. You have to fit the best curve in terms of linear regression, what we call linear regression, least square error minimization. Now, Excel does that. Add trend line. In this case, I have to have a linear equation, display equation on chart, display R squared value on chart. Y, which is X, which is the displacement, is equal to 0.3417x. X is F, notice, plus 0.2001. Okay? That's the result. R squared, this term R squared, shows us how good this fit is, how good your data points are represented by this equation. If it is 1, every point is on the line, which is almost impossible for any lab work or any experiment that you perform. Obtaining a R squared equal to 1 is making $1 million from the lottery. No way. If R squared is equal to 0.5, there is no relation between Y and X. Any curve will do. Okay, that's out. If R squared is about, depends on the problem. In heat transfer, in fluids, sometimes they accept a value of R squared 0.6, 0.7, because in their experiments, there are lots of errors involved. In case of mechanical experiments, R squared is usually greater than 0.95 or spring measurement, etc. is usually a good value, like 0.998. Okay. Now, in order to determine K is equal to 1 over 0.3417. 2.926 is the value of K, Newton per meter. Let me write that as well. Okay? The reason, let me repeat, the reason why we don't plot X, F versus X and obtain K directly is, in this case, we are assuming we have error on X, not on F. If we had done that, if we had F on the vertical axis, X on the horizontal axis, we are assuming that we have error on F, no error on F, on X. That's wrong. Okay, that's wrong. Let me repeat that, that's wrong. You have to do it this way. Any questions? Okay. Let me add another page. Ooh. I think maybe I think I can do this. Control C. I'll be quick. I will solve a mechanism case. This is a mechanism that I have found from a book known as Ortobelevsky, a Russian kinematician. They have compiled all kinds of mechanisms. This is a dual mechanism. But what I will do is I will forget about the links, the two links. I'll consider the 4-bar because I want to show you how you can perform velocity and acceleration analysis. If I do all of it, it will be a little bit more. I will not have time. So what I will do is I will solve this portion, okay? A, B, C, B, M, E. The link lengths are given in terms of AB. AB is the crank length. I will use, this is usually what happens, okay? In your classes, if you are using my book, you would be learning A0, B0, A, etc. In some books, it is like this, A, B, C, D, E, F, G. etc. In some others, there will maybe some other notation. You have to get used to it. Everybody has different notation to use. I claim mine is the best, but don't take it. Don't accept that. I will select AB equal to 1 unit. 1. That's it. In that case, AB is 1 unit. Please follow me from the figure. BC is 4.22. DC, GF, EM, EF, AD, AD, that's it. GD, BM, BM is what I need. BM is equal to MC. Yeah, it's the midpoint, so it's okay. That's okay. That's that much I need. AG, okay. DC, GF, EM is 3. EF is 2.33. AD is 3. These are the dimensions. A is the crank. This is how I normally solve such a problem. In Excel 2, I will be showing lots of different ways how to use macros to solve this problem. But now, right now, we are using straightforward procedure. First of all, I type in theta 1, 2. I'll be need symbol, subscript, theta 1, 2 is, I'll take 20 degrees, just for the hell of it. Okay. First, let me convert this. Oh, I think I have dr typed somewhere. So I will say this is equal to 20 times dr. I think I have it. Yes. dr converts degree to radian, degrees to radians. Okay. Normally, this number is 16 digits. But I see whatever I want to see. Okay, I mean, I can have two, I can only see 2 digits, 3 digits, it doesn't matter. Number one, what I do is, okay, this crank is at AB. I determine the distance from D to B in terms of X component and Y component. I call that SX and SY. This is what you may call stepwise method, Reynolds method. There are lots of other names that we have in the literature. This is equal to minus AD. Where's AD? Here. Plus A2, AB times cosine theta B11. Since B11 is closed, I do it like this. I press F4 to B8 and B2. The reason those are link lengths, they are not going to change by crank angle if I move it somewhere else. SY is equal to AB times sine of B11. Again, I type F4 over here. Then I determine the distance S. The distance S is DA distance. It is a variable distance. Or sorry, dB distance on this figure. I'm sorry. dB distance. It is a variable distance. Depends on angle theta. Theta 1, 2. This is equal to SQRT square root of this value squared plus D11, if it is over the cell, I type it myself. Let me check. C11, D11 squared. C11 squared, D11 squared. And then the angle phi, this angle phi is the angle that line DB makes with respect to the horizontal is equal to A10, but please use A10-2, because A10 will only give you angles from minus 90 degrees to plus 90 degrees. If you are going to obtain an angle that can be 180 degrees, or 270 degrees, etc., use A10-2. A10-2, Sx, comma, Sy. This function is always available in MathCAD, MATLAB as well. You have two different A10s, inverse tangents. One single argument, another double argument. This is a double argument inverse tangent. To get the correct quadrant, that's why you have to use it. A10-2, Sx, Sy. Another point is I have placed comma in between those two. Depending on your Excel, how Excel is installed, in some cases this is semicolon. For example, in my case, the computer that I use in my office is comma. At home, it is semicolon. Please note that. Phi is 2.977. This angle is divided by dr, if you want to see, it is 170.6 degrees. Is that correct? Minus, yes, 170.6 degrees, that's correct. And then I have solved BD. Now I have a new triangle. BD distance is S. I have BC, CD forming a triangle. I will measure the angle psi . Let me write it. Angle BDC. Angle BDC. And for that, I will use cosine theorem. Cosine theorem states that angle is equal to the adjacent sides squared minus the opposite side squared divided by 2 times the adjacent sides multiplied. I write it like this, is equal to A cos. This is inverse cosine. Open up parentheses, another parentheses. One adjacent side is S squared plus the other adjacent side is BC squared minus the opposite side is BC squared close the parentheses, divided by, open parentheses, 2 times S is closed, E11, E11, times B4. Close parentheses, close parentheses. I think I forgot some commas. This is some F4s. B4, I have to press F4. B3, I have to press F4. They are constant. B4, I have to press it. I don't press F4 to E11. It's going to change. It can change. This angle is 110 degrees. There's one last angle, and that is the transmission angle, mu. And that is equal to A cos again. It is the angle, let me write that as well later, BCD, this angle. A cos, adjacent side is, once adjacent side is BC, plus the other adjacent side is DC, minus the opposite side is S, divided by 2 times BC times DC. Now, press F4, press F4, press F4, press F4. These are the angles, mu, etc. Now, theta 1,4 will be equal to the angle phi minus the angle psi. Theta 1,3 will be equal to theta 1,4 minus mu. I may have done some mistake. So what I will do is, okay, what I will do is you have to give me 10 minutes. I'll draw the mechanism. I'll sketch the mechanism, animate it, and then stop. Sorry, I'll pass 10 minutes. I couldn't have time. Okay, what I do is A0, sorry, A, D, A, B, C. Oh, I'll do that as well. Yes, I think I can do it. Okay. E, I don't have an E, but I will do that. B, C, E, B, C, D. First, let me determine the coordinates of point E, okay? The coordinate of point E will be XE and YE, okay? XE will be equal to, starting from A, AB times cosine of theta 1, 2 in radians, plus BM. BM is half of BC. BC is this value divided by 2 times cosine of theta 1, 3, J11 Notice it is over there. Plus ME, EM, times cosine J11 plus pi divided by 2, pi over 2. Because the angle is 90 degrees. So I have to, theta 13 is the angle BC makes with the horizontal, 32 degrees. Now to it, I have added 90 degrees. Okay. F4, F4, F4. And XYE, again, remember I had a trick. Control C, Control V. Now, B2 sine theta 12, B12 3 over 2 sine, and sine. That's it. Now I can write it. A is 0, 0. Let me go to D. D is equal to AD is X coordinate, Y coordinate is 0. B is equal to AB times cosine theta 12. Y coordinate is equal to AB times sine theta 12. Oh, C, okay, C, let me write it over here. C is equal to the coordinates of D plus DC length times cosine of theta 14 in radians is equal to Y coordinate. This is 0, but I'm still typing it. DC times sine of theta 14. Ah, that's it. C is this value twice. E is this value. B is this value. Take these, use relative cell addressing, that's it. I have determined the coordinates of all these critical points. Now, insert, this time straight line between data points. Select data, first the crank, A0, AB. That's your crank. Okay. Add B, C, E back to B. Add B, C, E back to B. There's something wrong. Okay, I'll find that out. CD. This point must be wrong. E. Let me see. What happened? I'm sorry, this EM, this should be M and it should be F4. Okay. I have entered this letter wrong. One last thing you have to do. You have to get the scales on both X and Y the same. In GeoGebra, it does it on its own, but in this case, you have to do it. The best way is, okay, this crank is going to rotate 180 degrees. So start from -1, go to 5 in steps of 1, okay? Start from -1, go to 5 in steps of 1, okay? Now you have to see these grids as a square if you want to have a correct scale. Okay. Now, what you can do is, I'll show the remaining later. I'll keep this. You have to go to Files, Options again, Customize ribbon. Over here, you have this developer. Normally, this developer is not turned on. That menu is not turned on. Please turn it on. Because if you do so, here you are going to have this developer. In this developer, you have insert. I will use the spin button. Oh, sorry, I am in the, I cannot, okay. This spin button. Properties, I'll be very fast. Minimum 0, maximum 360. Relating that cell to the button to A11. Small change. Let me take 5-degree increments. This is a very, very fast way of doing it. That's it. Close the design mode. Now what you can do is, oh, I have to change the scale, the limits. -3 will be good enough. Okay, that's correct. The rest, how to draw the coupler curve, how to determine the output as a function of input, how to take the derivative, etc. I'm sorry, I cannot do that. I will do it in Excel 2 tutorial seminar. I think this will be all for now. I'm sorry I kept you waiting a little bit more than I expect. Let me repeat, I will save this. I will save this and post it somehow later. I'll close it. If you have any questions, I will be glad to answer.